Hello, my name is Preston Durbin, and I did my blog post reading on Lincoln and Mandela. And this particular blog I read went over random assignment versus random sampling. And the material that will be covered throughout this entire presentation is defining what random sampling and random assignment really are. And then we'll dive straight into how the Lincoln activity that uses random sampling. Then after that, we'll talk about the Mandela activity using random assignment. And altogether, we'll consider the differences of random sampling and random assignment. But first off, random sampling versus random assignment. So random sampling concerns how to select observational units from a sample and it allows for generalizing the results of a sample to the larger population. While as the random assignment pertains to how observational units come to be and groups to be compared. And random assignment also allows for the possibility of drawing a cause and effect conclusion. And moving on, we have the Lincoln activity. And this activity is about reading the Gettysburg Address. And actually, we went over this in class once already. But the first question that is being asked to the students is, what speech is this and who wrote it? So this includes a little bit of a history, cross-curricular activity involving statistics. And I feel like it's a really good one for history and to teaching stats. But for the first steps that they have to take are the circle 10 words as a representative sample from this population. Then they have to, for each word in your sample, record how many letters are in the word. Then step 3 is to calculate the average, the mean number of letters per word in your sample. Then the last thing they will do is plot the sample average on a dot plot on the board, along with the sample averages of your classmates. And this will be a board that's just right in front of them that they can all see in the classroom. And moving on, students will be asked to identify the observational units and the observational variable first in the student sample and then on the graph on the board. You should expect the students to come to the conclusion that the observational units from their own sample are words, with the variable being the length of the word. But from the board, it's actually quite different. At first, when I was reading, I didn't think there would be a difference, but there's like a very slight difference. And this is the observational units are samples of 10 words, and the variable is the average length of the word, which is very similar to the student sample. Then you ask the question, how can we use the dot plot on the board to tell whether the sampling method is any good? And what additional information would you like to know to help you decide whether the sampling method was good? And this gets them thinking about the sampling method. And then we wait for the student's response to lead to the average word length of the population. And right here, we have the average population or the average mean for every single student's dot that they've collected. And the little line that was provided by Alan Rossman is actually the real Gettysburg average. And we can see that there's a little bit of a difference. This is where you would move on to define sampling bias to students as a systemic tendency for sampling method to overrepresent some observational units and underrepresent others. Then the next question you would ask these students are, would you say that this sampling method is biased? And as we can see from this, a lot of students overestimated the mean, the actual mean. And so they should draw to a conclusion that there's an overestimation of a word count. Then you would emphasize to students that sampling bias is a property of the sampling method. And you would ask the students for some explanations for sampling bias, and some of them can include the meaning of the words, human choice, or just the fact that some longer words are just a little bit better and they're more willing to pick longer words because it just has more meaning, and they're less likely to grab words that say the or is. And then you would finish this discussion by asking the suggestions from students on different sampling methods that would be unbiased. And the best one that they have, or the best conclusion that they should come up to, is the idea of random. And students study properties of random sampling by using technology. And the best one that Rossman showed us is a little applet that he collected for this particular activity in the Rossman/Chance applet collection. And this applet will be more accurate because it includes random sampling. Then you would ask the students if the random sampling method is biased, and they should come to a conclusion and say no. The mean is closer to the population mean. So students will also struggle with the following statement: the mean of the sample means is the population mean. And right here, I divided it up a little bit. So we go into the population mean. They should know that for the population of 268 words, in the Gettysburg Address, the values of the population mean is 4.295 letters per word. And then the next difference is the sample mean, and each student calculated their own sample mean and represented it with a dot on the board. And then the last one's actually the mean of the sample mean, but I couldn't color code it all together because it would be dividing it up. But the mean of the sample mean is gathered from the applet that turned out to be 4.336 letters per word in the particular study that Alan Rossman was working with. Then now we move on to the Mandela activity, and this will cover the discovery of random assignment and starts off with asking 2 questions about Mandela. The first version that these students will be working with is, or some students will be working with, is: was Nelson Mandela the first president of South Africa following apartheid younger or older than 16 years old when he died? And then version B that other students will be working with was Nelson Mandela first president of South Africa following apartheid younger or older than 160 years old when he died? Now, students don't know that there are 2 different versions of the same question, but there's a small difference. And version A says 16 years old, and version B says 160 years old. And the research question for this activity are people's age guesses are subconsciously affected by first seeing the number 16 or 160. And this brings into a psychological phenomenon called anchoring that suggests those numbers, despite being completely irrelevant, nevertheless affect subsequent responses. Then you would collect student responses for both versions by splitting the class up with adding all the numbers found in their birthday. For example, it's my birthday, and I was born November 28, 2000. So then you would add all those numbers up, and then you would determine if it was odd or even. And if you had an odd number as the result of your birthday, you would do version A. And then if you had an even amount, then it would be version B. And after the collection of the student responses, you would reveal the 2 versions to students and their research question. And we have 6 questions for the students to discover. And the first question are, what are the observational units? And in this case, the students are. Second question is, what are the variables? And the explanatory variable is 16 or 160 years. And the response variable is the guess of Mandela's age when he died. Third question is this an observational study or an experiment? And we have an experiment in this particular case, as it is controlled by the teacher. And the fourth question is, did this study make use of random sampling, random assignment, both, or neither? In this case, we only had random assignment, and we're going to go more into detail about that later. And the fifth question is, some students know more about world history than others. Is this a confounding variable here? And this is no, because it's only focused on the population in their class. And then the sixth question is, if it turns out that the age guesses in group B are statistically significantly greater than the age guesses in group A, would it be appropriate to draw a cause and effect conclusion? And you can here, and this will be a key detail for random assignments. And these are the results from the Mandela activity. And you can see that we had 2 outliers In version A, we have 16, or I believe that's actually going to be 14, sorry. And for version B, the outlier is 140. But from the sample data, it provides strong evidence for an anchoring phenomenon. And this is because of the mean age only differs by 18 years between both versions. The median differs by 11.5 years for both versions, and the p-value for the t-test is essentially 0, which supports the hypothesis. And students will be questioned whether any values should be removed from the analysis. And this is when I mentioned earlier with the 14 and the 140 years being outliers. And this is actually implausible for, well, one, for someone being there alive for 140 years is nearly impossible. And this could be because students just didn't really fully understand the question, and they probably just misunderstood it. But by removing those it's still strong evidence for anchoring phenomenon without extreme data values. And then now the students can conclude that this is appropriate to draw a cause and effect conclusion, and the larger anchor number tends to produce greater age guesses than the smaller anchor number. And no data to address the population for this study. And for final statements, the aim to help students understand the difference of random sampling and random assignment is very crucial. And Alan Rossman has 2 blogs that really go over these 2 ideas. And it's just a lot of information that is crucial for students to fully understand. But with what students really need to understand is that, or the goal for each assignment for random sampling, you have to select a sample that is representative of the population in all respects. And then the goal for the random assignment is to produce groups that are as similar as possible in all respects, except for the treatment being assigned. Thank you.